Jan, your work on the galactic models led to the realization that there is dark matter at large radii, and that led you in a rather natural way to the theory of galaxy formation, I believe, and that in turn then led to what we now call the discovery of the cosmic web. Can you maybe tell us in what steps that process developed?
Actually, the web story started in '74 when I made a report on the dark matter on this Seldovich seminar in winter school. And my basic point was that it is a new population, and the total density to the dark matter is roughly 20% of critical cosmological density. And I also showed that no known form of matter, no stars and no hot cold gas can be responsible. And for Seldovich, it was a great surprise. He was interested in the formation of galaxies, but he didn't know that something new is in this stuff. And
Yes.
so he and his collaborators started to think, and we started to think together. And then, in the same evening, he invited me to his apartment in the school, made suggestions that our team helps him to find some observational evidence which can be used in order to discriminate between different galaxy formation scenarios. It was one by Seldovich, then by Ozanoi, the viral theory,
Yes.
and then by Peebles. But at this time, it was not known what to do, what we have to search.
Yes.
And initially, we had no idea, absolutely no idea. Our team was concentrated attention to galaxies, not to cosmology in general. And Saar, who joined our team, he was theoretical cosmologist, no open or closed universe or something like
but
this.
no observations.
Nobody had experience, so we started to think what to do. And the basic argument we found from our previous experience was doing galaxy populations. Galaxy populations are very stable. That means they hold kinematic structure for a long period.
Yes.
That means for, studying the present stage, we can make conclusions on the previous. No, Linden-Bell, Sandy-Chapeau. It is just the same point of view. And then, when we estimate, galaxies are small, maybe maximum 100 kiloparsecs.
Yes.
If we look larger volumes, megaparsecs, 100 megaparsecs, this must be even more conservative.
Yes.
It must the present stage must reflect initial stage.
Yes.
And then we got the idea, in order to understand the problem, then we have to study the large-scale distribution of galaxies. What this means, what comes out, we didn't know. We had no idea what comes out. It was just for us also a surprise.
Yes. And then the standard ideas that perhaps the universe was isotropic and beautifully homogeneous were turned out to be not completely correct. Because what did you find?
What we found, actually, we in our team we had 3 different approaches, because we didn't know beforehand which approach gives results.
So you have
One
to try.
is just we built using Zwicky clusters, wide Zwicky, because the density, spatial density is more than 10 times higher than Abel cluster. So it is better, how to say, shows large scale structure.
Yes.
Then one collaborator studied in Palomar plates individual galaxies, clusters, and Mihkel Jõeveer, he came to the idea just before we started. These wedge diagrams were invented.
Yes.
That means location where distances and angular distance. So you see the spatial distribution. And second, plots of the objects all clusters we could have and individual groups or so. And important was we excluded very distant objects, only nearby. So the spatial structure could be seen on face and in distance.
in the wedge diagram.
And then we saw that there is structure. That means clusters, they form giants,
Yes.
as we called them initially. No, now filament is.
We now call them
called,
filaments,
yeah.
yes.
And they join superclusters to a single network. We used first cellular structure because Seldovich numerical simulations gave roughly, very roughly,
Yes.
this result. But later we understood that there are no pancakes, no flat surfaces, only these tips,
Yes.
knots,
And the
not
filaments.
clusters, and filaments. And small sheets, but not complete, isolating this alone,
Yes.
and voids.
Yes.
And second, what this we did also with Michel, we looked the detailed structure of these clusters. In Perseus supercluster, all clusters were elongated along the side. Main galaxies in these clusters they were all spatial types. Is a supergiant,
Yes.
or radioactive, that means X-ray.
Yes.
That means spatial. That means they are physical systems and some physical processes which are connected to large scale.
So, indeed, but getting to these results, there was also work being done in the West. Various conferences were important. How got all of this accepted?
Actually, Seldovich wanted to have an international conference on cosmology. He made already one attempt,
Yes.
73 in Krakow, but then his results were not accepted, and he wanted to do something more. And it was clear that only within Soviet Union or the socialist countries
Yes.
it is possible, because Soviet people cannot go to Western countries. So his suggestion was to have it in Tallinn. No, it's easier
Yes.
to organize as in Moscow. And so we started preparations. I was happy to be 73 in IAU.
Yes.
To be in the meeting of the scientific organizing committee. So the basic question was who will be the head of the organizing committee. I suggested Malcolm Lonkair because he was a few years before in Moscow, worked with Seldovich,
Yes.
and he was familiar with the Soviet system, and Seldovich trusted him. So he was the head. It was a very good choice because
Yes.
he was extremely good organizer. So, and the general, agenda was accepted. At this time in 73, we didn't know still what the results are.
No.
Only next year we got basic results. And when the conference really took place, then 4 different groups had similar results. One was Brentali, local
Yes.
supercluster. He used his
Yes.
radio observations, neutron hydrogen line, and then one was what was later published by Gregory Thompson, Coma supercluster,
Yes.
and one group Hercules supercluster. Basic results were the same. Superclusters are much bigger. They contain filaments, and there are filaments, voids between them. And in our case, and it was only in our report, we got the whole network. We couldn't observe ourselves, but we used the whole northern hemisphere, and then this was needed to see the whole picture. Filaments joining superclusters to a network. And also these physical aspects,
Yes.
active galaxies and so on. But at this time people understood, but I made one error in my representation in this. I cited Seldovich's work as one possibility to explain it. And actually, this was not understood as a strong argument for Seldovich and against Peebles. And at this time, it was looked from the East-West confrontation. Yes. And only later scientific arguments were, but it came later.
And the outcome was, as far as I understand it, that the Zeldovich pancake theory was not the whole story, but it is part of the story, as is the hierarchical part of the story, which was the Peebles part.
Yeah.
And therefore, it worked
Actually,
out very well.
Both are right.
Yes, exactly.
But the sequence of events is a little bit different from that what was supposed initially.
Yes.
But this is natural. We don't know.
That's how we do science.
Yeah.
Very
the
good.
First, how to say, physical event is just collecting particles to collapse from different sides. This is a pancaking process, and inside pancakes, systems form and start hierarchical clusters.
Yes.
Both processes work.
Perfect. Let's stop here for a moment.